Dear all, I am Ramesh and I deal with mathematics. Mathematics is the mother of all sciences. To build a career also, mathematics plays a very big role. We are here to train you in approaching the complexities of mathematics for competitive exams. Trigonometry is a branch of mathematics that studies the relationship between side lengths and angles of triangles. It is made up of two parts, trigon and metron. Here, trigon means triangle and metron means measurement. So, the word trigonometry literally means triangle measurement. This field emerged in 2nd century BC. This is Hipparchus. He is known as the father of trigonometry. He is the first person to study the relationship between chord length and angles. Angles means the central angles. So we can say the concept of trigonometry began with Hipparchus, and he denotes the variation of chord length according to the angle of a unit circle. This concept was further elaborated by Ptolemy in 2nd century AD. This is a point and this is locus of all points which are equidistant from a fixed point, and that fixed point is called circle center, and this is called, that locus of these points are called circle. This is a chord and these is called central angle. Hipparchus did a work such a way that he measured the angle, that central angle, and record this chord length according to the central angle. Aryabhatta is a mathematician and astrologer. He used first concept of half the length of chord, and that later on magnified as sin theta. So, what is sin theta? We may by heart the value sin theta, cos theta, tan theta, but actually what is sin theta? It is actually the half length of chord of unit circle. Why do we learn trigonometry? Let us look at a simple example. This is a great monument symbolizing the contribution of Sardar Vallabhbhai Patel in uniting 565 princely states into Indian Union. Do you know height of this monument? Suppose you don't know the height of this monument, we are calculating that with the help of trigonometric functions. Let us discuss. Suppose I am standing here and I need to find height of this monument, and I walk from here to here. A certain distance I walked, and I view I notice the distance travelled, and it is equal to 182 meter. Then I watch the top of the statue and I notice the angle of elevation. It is called angle of elevation. I find it as 45 degree. I can use a kilometer to view this angle. Suppose you don't have a kilometer with you, your mobile phone you can turn into kilometer by some applications in Play Stores. So anyway, I measure the angle as 45 degree. Now I want to find the height. So I know tan 45 is 1. We will discuss later that topic. Instead, now I am going with that relation. Tan 45, know that it has 45. So I know tan 45 as opposite side by hypotenuse. So I take tan 45 as opposite side by adjacent side. So not hypotenuse, it is opposite side by adjacent side. So here opposite side is this height and adjacent side I know it has 182 meter, that distance I travelled. So I replace that 1 equal to 182 by h. Now 182 by h, by crossing we get h as 182 meter. So the height of Sardar Vallabhbhai Patel's statue is 182 meter. Now look, a circle, here OP is a radius. I consider a unit circle, so OP is equal to 1 unit. And this length is also equal to the same as that of OP. I construct a chord here and I don't know the height or length of the chord, but I can simply say the chord of this half length is equal to sine theta. So I divide the entire plane into 4 quadrant and I can say this is positive axis x, this is positive y axis, this is negative x axis and this is negative y axis. In this case, first quadrant, second quadrant, third quadrant and the last one is fourth quadrant. Now this is angle theta. The opposite side is called sine theta. So this is sine theta, its value is sine theta when this is a unit circle. Now we need to find cos theta. So if this side, this adjacent side of this theta, angle theta is called cos theta. So I represent it in black color. Now we know tangent is simply known by the name tan. Actually that tangent is a straight line passing through a single point of circle. Here if you draw a straight line, we can say this length as tan theta. So actually sin theta, cos theta and tan theta are really functions and ratios. We can simply say it as ratio of distance. That is why sin theta by this one for a unit circle, sin theta by this one is actually value of sin theta. And thus sin theta is independent of units. It is a ratio, so it is independent of units. Let us discuss how it varies accordingly with the angles. You know, here sin theta I am representing in red color, cos theta in black color and tan theta in green color. Now if my theta decreases, the value of sin theta decrease. Correspondingly, the value of tan theta decrease. But what happened to the value of cos theta? Value of cos theta increase. You can view the another angle. So in this case, theta is too much small and that sin theta is further reducing, tan theta is reducing, but the length of the cos theta, the value of cos theta increases, further increasing, and cos theta will be maximum, and at that time the value of cos theta will be equal to 1. That means the unit circle's radius. But at that time, where is our tan theta and where is our sin theta? These two are missing from the graph. That means they are nullify, means approximates to 0 or exactly equal to 0. That is why we can say sin 0 is 0 as well as tan 0 is 0. Now we are going to increase the value of theta in a regular manner. So we just increase this value, we get sin theta, we get tan theta, and also we have that cos theta. while I am increasing, it increases gradually, the value of sin theta increases and the cos theta decreases, tan theta increases, and it will be increased again, and this cos theta will decrease, is very small at that case, and further case at 90 degree, the cos theta, the black color, vanishes, means cos 90 is equal to 0. And what about the sin 90? At that case, sin 90 is maximum, means sin 90 maximum value is actually, it's a unit circle, so the maximum value is 1. So it get the value of sin 90 as 1. And value of tan 90, the value of tan is actually the length of this line. It will not touch the x-axis. It is parallel to x-axis. So we can say tan 90 is infinity. So we can say tan 90 is not defined. Let us discuss how can we find tan 45, sin 45 and cos 45 with the help of this triangle. So this is actually theta 45 degree. At that case, we have sin theta, this is sin theta, we have cos theta, and we know this value which is equal to 1. You know this is tan theta. But this angle we can calculate, or we even know, we know that the radius and tangents are perpendicular to each other. So it is exactly 90 degree. So this is 90 degree. So 90 degree, then how can we find this theta 2 second degree? Theta 2 we can denote it as theta 2. So that theta 2 is actually unknown. But you know, in a triangle, sum of 3 angles is equal to 180 degree, for which 90 is there and this is 45 degree. So we can simply say that theta 2 is 180 minus 90 minus 45, which is equal to 45. So it is an isosceles triangle. If two sides are equal, it is called isosceles triangle. So these angles are equal. Here 45 degree, here 45 degree. So two angles are equal to 45 degree. Two base angles are equal to 45 degree. Then we can say it is an isosceles triangle. What do you know the property of isosceles triangle? The angles opposite to equal sides are equal. Also, the sides opposite to equal angles are equal. So here, equal angles are we have. So sides opposite to equal angles means the sides, this side and this side. These two sides are equal. So we can say if these two sides are equal, this is unit circle, 1 unit, then this is equal to tan 45. Tan 45 is equal to 1. Now we can find the length of the other sides, means other sides of the smaller triangle. That means sine, we need to calculate sine and cos. In the case of sine and cos, you know this sine and cos are equal. So that is why we get tan 45 as 1. One more thing, you need to calculate this length. How to calculate? Now this is 45 degree and you know this is perpendicular, means it is 90 degree, then the remaining part, this one is 45 degree. If these two sides are these two angles are equal, then sides opposite to equal angles are equal. So that means if this is x, this is also x. This is a unit circle, then it is 1. So now we can calculate the value of x. From Pythagoras theorem, you know that base square, this is x square plus altitude square, here it is again x, then x square, which is equal to this 1 square. Now we can say 2x square is equal to 1 and x square is equal to 1 by 2. Now we can easily calculate the value of x, which is equal to 1 by root 2. So this x is equal to 1 by root 2. Also this x is equal to 1 by root 2. Now we can easily find the value of sin theta. Sin theta is actually, you know, sin theta is actually opposite side by hypotenuse. What is the opposite side of this theta? Opposite side by hypotenuse. Why we are saying that hypotenuse? Actually, its sin theta is a ratio where opposite side by hypotenuse side. Actually, sin theta is a ratio of opposite side by hypotenuse. But if you consider unit circle, it is just opposite side. So sin theta is actually opposite side. What is the opposite side here? Theta is the angle, opposite side is 1 by root 2. So we can say sin theta equal to 1 by root 2. So we can say sin 45 equal to 1 by root 2. And also cos 45 is equal to again 1 by root 2 because of this property. Let us consider another example. Central angle is 60 degree, and you know, if this angle is 60 degree, I can draw another line joining M to P, where that MP is equal to the radius. Why? How we can say? This is one unit circle, this is 1, this is OP, which is also equal to 1, and this angle is 60 degree. From the property of triangle, we can calculate these two angles. These two angles are equal since it is opposite angles opposite to equal sides. So let us take these two are x and add all these three angles will be equal to 180. From there we can calculate these two angles and we get it as x 60 and 60. So we get it a equilateral triangle. In that equilateral triangle, all sides are equal since this is also 1. And also we can find the altitude of the equilateral triangle by a property, by an equation root 3 by 2 A. The A is side of the triangle, so root 3 by A is actually 1, so root 3 by 2, here we get root 3 by 2. Now by using Pythagoras theorem, we can calculate this ON. This is ON. That means the length of cos theta. So we can say this value by square root of 1 square minus this value is root 3 by 2, the whole square, and on solving we get it as 1 by 2. So this value is 1 by 2. Now it's very easy to find sin theta. Sin theta, here theta is 60 degree, so sin 60 degree. Sin 60 degree is opposite side by hypotenuse. Hypotenuse we are taken as 1, so opposite side, just it is opposite side, that means it is root 3 by 2. Actually root 3 by 2 by 1, so by 1, since there is no need to write that by 1. Next, cos 60 degree. Cos 60 degree is actually adjacent side by hypotenuse, or simply it is the black color. The black color is 1 by 2 for a unit circle, it is a black color. So it is 1 by 2. And what about the tan 60? Tan 60 actually is this length, but we can say is sin 60 by cos 60 as tan 60, since it is slope. So we can say root 3 by 2 by 1 by 2, we get root 3. Now how to find sin 30? For finding sin 30, cos 30 and tan 30, we can say we should take this angle is 30 degree. Since this is 90 degree, this is a right angle triangle having 60 degree and 90 degree, the third angle must be 30 degree. So we get 30 degree. So opposite side by hypotenuse is sin, so we can say sin 30 is equal to, opposite side is 1 by 2 by hypotenuse is 1. So sin 30 is 1 by 2. Now what about the cos 30? Adjacent side. What is adjacent side of this angle 30 degree? This one is root 3 by 2. So we get answer root 3 by 2 divided by 1, but it is simply root 3 by 2. What about the tan 30 degree? Tan 30 degree, we can say sin 30 by cos 30, which is equal by 2 to cancel, and we get 1 by root 3. For memorizing the values of sin, cos and tan theta, we can simply say this is 0 by 4, square root of 0 by 4, square root of 1 by 4, square root of 2 by 4, square root of 3 by 4 and square root of 4 by 4 for just memorizing the value. So we can say sine 0 is 0. We actually realize the way in which sine 0 is 0. So angle is 0, the sine value is disappear. The sine value is actually in our problem it is denoted in red color. That value is not anywhere in our picture. So that is why it is 0 and its maximum value is 1. 4 by 4 is actually 1. This is, we can simplify it as root 3 by 2. We by heart this root 3 by 2 and this is actually 1 by root 2. This is actually 1 by 2 and this is already 0. And you know the way to write this cos function, and the last one is here 1 and the first one is 0. To memorize we need to by heart these 1 by 2, 1 by root 2, root 3 by 2 in 30, 45, 60. Sine 30, 45, 60 is 1 by 2, 1 by root 2, root 3 by 2. Sine 30, 45, 60, 1 by 2, 1 by root 2, root 3 by 2. And just opposite way, 1 by 2, 1 by root 2, root 3 by 2. You need to by heart the same 1 by 2, 1 by root 2, root 3 by 2. For sine it is 30, 45, 60. But for cos it is 1 by 2, 1 by root 2, root 3 by 2. But it is in the way 60, 45, 60, 45, 30. So only thing you need to by heart is 1 by 2, 1 by root 2, root 3 by 2. For a convenience, you need to by heart 1 by 2, 1 by root 2, root 3 by 2. But in the case of sine, it is 1 by 2, 1 by root 2, root 3 by 2, 30, 45, 60. But in the case of cos, it will be 60, 45, 30. 60, 30, 45, 30. That is the only difference. So I am concluding what I am discussing earlier are just to visualize the sin theta and sin theta, cos theta and tan theta. That will help you to learn the topic more interestingly. But actually for an exam point of view, you need to by heart these values. And while dividing these values, we get tan. Now I am going to discuss equations we need to by heart in examination point of view. First I draw a regular hexagon and I denote these functions. I didn't say anything about these three functions. These are new for us. They are, first I write sin theta and its co-function is cos theta. So sin, cosine actually it is, but we should write it as cos theta. So sin and its co-function cos theta. Tan, its co-function is actually cotan, that is cot. Now sec here, sec its co-function is actually cosec. So sec, cosec, sin, cos, tan, cot, sec, cosec. Actually we need to write small c in case of sin and cos or all other trigonometric function. The typographical error. So we should write small sin, small s. Now if you need to find tan theta, just sin theta by cos theta is tan theta. So we can say tan theta equal to sin theta by cos theta. You know that. Suppose you need to find sin theta from our hexagon, you just write sin theta equal to cos by cot theta. Now if you need to find cos theta, we can simply say cos theta equal to cot theta by cosec theta. Now if you need to find cot theta, successive one, cosec theta minus sec theta, sorry, divided by sec theta, cosec theta divided by sec theta will be your answer. So sec theta will be equal to tan theta by sin theta. So we get all types of equation from this simple hexagon. Another use of this hexagon is that suppose you need to find in anti-clockwise direction, you know cot theta is equal to cos by sine. Cot theta, if you need to find cot theta, so it is cos theta divided by sine theta. Suppose you need to find cos theta, then we can say it is sine theta by tan theta. So it is works in clockwise direction as well as anti-clockwise direction. Now I put a 1 here and vertically opposite sides, considering vertically opposite side, sine theta into cosec theta equal to 1. Similar way, tan theta into cot theta is equal to tan theta into cot theta equal to 1, and here also sec theta into cos theta, sec theta into cos theta equal to 1. So vertically opposite angles, so opposite of our super hexagon is always the product as, getting a product as 1. Now I explain one more importance of this 1 here. I am writing 3 special figures. You know, a square relation, sine square theta plus cos square theta equal to this 1. So this 1 plus cot square theta, if square comes here, if this 1 plus cot square theta is cosec square theta, at that time square we need, 1 plus cot square theta, cosec square theta, and here tan first, tan square theta plus 1 is equal to sec square theta. So all square relations are comes under this super hexagon. So sine square theta plus cos square theta 1, cos square theta, now this one, not this one, 1, from this here 1 plus cot square theta equal to cosec square theta, and also tan square theta plus 1 is equal to sec square theta. And already we discussed that sine and its cofunction, tan its cofunction, sec its cofunction. Also vertically opposites are reciprocal. Sine reciprocal is cosec, cos reciprocal is sec, and tan reciprocal is cot. Now we come to some questions. Tan 1 degree, tan 2 degree, tan 3 degree, etc., tan 89 degree. This is a case of plane. We are dividing into 4 quadrant, and any theta we are writing here. Now in this first quadrant all values are positive, means this is our cos value, this is our sine value if this one is 1, or this is opposite side, this is hypotenuse, and this is adjacent side for any big values. Anyway, if you need to find sine theta, we need to take opposite side by hypotenuse. Both opposite side and hypotenuse in this case is positive number, are positive numbers. So we can say always the sine value is positive in first quadrant. Similarly, in first quadrant the cos value is positive, tan value is positive, and all other trigonometric functions are all positive. So in this first column it is all positive. We will discuss about the second, third and fourth quadrant in upcoming classes. So in first quadrant always all are positive, but some change happening according to the cofunction. If a theta sine 90 minus theta is there, if sine 90 minus theta, cos 90 minus theta, tan 90 minus theta all are in first quadrant, but it is not like that. Sine 90 plus theta, sine cos 90 plus theta are all in second quadrant. So now I am discussing only about the first quadrant. So we can simply say in first quadrant all values are positive, but in respect to the active axis, so this is actually standing line, this is sleeping line, we can say this is standing line and this is sleeping line, and a value according with the standing line will change. Standing line is active line, so we can simply say this will change it to its cofunction. That means sine 90 minus theta is equal to cos theta. Sin 90 minus theta is always be equal to cos theta. Similarly, cos 90 minus theta will be equal to sin theta. This change happening only when the angle rewrited in terms of the standing line. Standing line means this is 0 degree, this is 90 degree, and this is 270. In according with the 90 or with the 270 comes here, that will change to its cofunction, and we will discuss later more about that. So anyway, it is now changed. Similar way, in this case, sine will change to its cofunction cosine or cos, tan will change to cot, and sec will change to cosec, and vice versa. So here tan 1 degree and tan 89 degree. For a simplification, instead of solving that in this traditional way, you just understand that if theta 1 plus theta 2 degree is 90 degree, then we can simply say it's tan theta 1 into tan theta 2 equal to 1. Product of theta 1, tan theta 1 into tan theta 2 is equal to 1. So we can simply say tan 1 degree into tan 89 degree equal to 1, since that 1 plus 89 is equal to 90 degree. So all such cases are equal to 1. So we can say tan 1 degree is here, tan 89 degree is here, the product is 1. Similarly, tan 2 degrees here, definitely a tan 88 be there, so that products to 1, another 1. So how many such ones are there? Almost all numbers are 1, x, and the middle one tan 45 does not have any pair, but you know that tan 45 is already 1. So all are 1. So product of all 1 is equal to another 1. So we can say answer to this question as 1. Question number 2, it's a simple question, cos 1 degree, cos 2 degree, cos 3 degree, etc. cos 90 degree. Here we need to note that 90 degree. You know cos 90 degree is 0. So product of any number with 0 is 0. So there is no other choice, answer 3. Question number 3, cot 15 degree, cot 30 degree, cot 45 degree, cot 60 degree, and cot 75 degree. Here cot 15 and cot 75. Sum of these angles which is equal to 90. What is the property of 90? 90, if theta 1 plus theta 2 equal to 90 degree, then tan theta 1 into tan theta 2 equal to 1. If tan theta 1 into tan theta 2 is equal to 1, but the reciprocal of tan theta in superexample just opposite value. So tan theta just opposite value is cot theta. So cot theta reciprocal of tan theta, and this is reciprocal of tan theta 2, cot theta 2, and will be equal to reciprocal of that one. One reciprocal is again 1. So we can simply say if theta 1 plus theta 2 is 90 degree, then tan theta 1 into tan theta is equal to 1. Cot theta 1 into cot theta 2 is also 1. So in this case, that cot theta 1 into cot theta 2 is here. So this is product to a 1. This is also 1. Cot 45, you know, it is 1. So we can simply say answer is again 1. Question number 4. Tan 10 theta into tan 8 theta equal to 1. You know, this happens only when the value of theta 1, this is theta 1 and this is theta 2. This happens only when the value of theta 1 plus theta 2 equal to 90 degree. Here theta 1 is 10 theta and theta 2 is 8 theta. So total 18 theta equal to 90. So what you need to find? You need to find tan 6 theta. So 6 theta, for getting 6 theta, we need to divide both sides by 3. So at that time, 6 theta equal to 30. So the question is very simple now. What is tan 6 theta, which is tan 30 degree? You know, tan 30 degree is 1 by root 3. So our answer is first option. Question number 5. Here cot 7 theta into cot 5 theta equal to 1. So similar way, 7 theta plus 5 theta will be equal to 90 degree. So we can say 12 theta equal to 90 degree. You need to calculate 6 theta, cot 6 theta. So 6 theta means half of this number, which is equal to 45 degree. So you need to calculate cot 6 theta. So that means you need to calculate cot 45 degree. You know cot 45 is exactly same as tan 45. Tan 45 is 1, then cot 45 is again reciprocal of that one, which is equal to 1 itself. So answer is fourth option. Question number 6. Tan A plus B into tan 2A minus B equal to 1. Same model question, but you know you hear A plus B plus 2A minus B equal to 90 degree. This B and minus B cancel, total of 3A equal to 90 degree, and we need to find tan A, then means A equal to 30 degree. Now we can say tan A is tan 30 degree. Tan 30 degree is 1 by root 3. You need to by heart that values. Tan 30 is 1 by root 3. And tan 60 is root 3. Tan 45 is 1. You need to by heart these values. You should not go dividing sin theta by cos theta, you get tan theta. You should not go like that. For a competitive exam aspirant, you need to by heart tan 30 as 1 by root 3 and tan 60 as root 3. You need to by heart, and tan 45 1. So here tan 30, which is 1 by root 3, here it is. Question number 7. Here 1 by 1 plus tan square theta. So we can say 1 by 1 plus tan square theta is actually sec square theta. So 1 by sec square theta plus here 1 by 1 plus cot square theta is actually cosec square theta. So 1 by sec, you know 1 by cos is sec, so then 1 by sec is cos. This is cos square theta. 1 by cosec, actually reciprocal of sine is cosec, automatically reciprocal of cosec will be sine. So we can say sine square theta. And you know cos square theta plus sine square theta, which is 1. So our answer is 1. We can go with the help of our super hexagon. Sine, cos, tan, cotan or cot, sec, cosec. This is actually super hexagon. In this case, 1 plus tan square theta. This is 1. Sine square plus cos square. Sine square plus cos square is 1. 1 plus, this is the root, 1 plus cot square. 1 plus cot square is cosec square. So here 1 plus cot square is here. So we can replace that 1 plus cot square as cosec square theta. So this is cosec square theta. Now tan square plus 1 is sec square. Tan square plus 1 is actually 1 plus tan square. So we can replace this 1 plus tan square as sec square theta. So this is sec square theta. So that what we get here. Now reciprocal functions. Just opposite is actually reciprocal of our super hexagon. So 1 by sec square. Where is sec? Sec is here. Its reciprocal is cos. So we can say 1 plus sec square replaced as cos square. So we can again 1 plus cosec square. Cosec square is here. Its opposite is sine. So we can say its reciprocal is sine. So 1 is sine square. So cos square plus sine square. What is cos square plus sine square? Here it is sine square plus cos square is equal to 1. In super hexagon, sine square plus cos square is 1. So we can say sine square plus cos square, final answer as 1. If you don't know this equation, then also we can solve this question by just assuming any value for theta. Let us take theta as 45 or like that, and we can substitute this value and we get a result, and that result we can take from here. but I strongly recommend a method instead of substituting values, because it is time consuming. The substituting the value may take more time. If you know the real trigonometry, then we can easily solve that question with the help of equating that equations. Question number 8. Here, cos A minus sin A the whole square. You know, A minus B the whole square is actually A square minus 2AB plus B square. A plus B the whole square is A square minus 2 plus 2AB plus B square. While squaring, we know this is actually cos square A plus sin square A minus 2 sin A cos A. Out of which cos square A plus sin square A, you know, this is cos square A plus sin square A minus 2 cos A sin A. So this function cos square A plus sin square A is 1. So this is 1 minus 2 cos A sin A plus, while solving this one, cos square A plus sin square A minus 2 cos A sin A. Out of which cos square A plus sin square A is again 1, as similar to this first case. So 1 minus this is 2 sin A cos A or cos A sin A. This is plus actually. This minus 2 cos A sin A plus 2 cos A sin A cancel each other. So finally 1 plus 1 we have, a total of 2 we have. So answer to this question is 2. We can solve this question in another way, that is, we can substitute any value for that A and check whether your answer is here. So let us take an example of theta or A as 0 degree. Cos 0 1, 1 minus sin 0 0 the whole square, plus this is cos 0 1 plus sin 0 0 the whole square. So what is your answer? 1 square plus 1 square. 1 square plus 1 square is 2. So answer is 2. And here also we get the same result. Question number 9. Now I am applying the same logic here also. Let us take any value for this A. For example, let us take cos A as 0 degree, A as 0 degree. So at that time, I get root of 1 plus cos A. Cos A is cos 0 is 1. 1 plus 1 by 2, answer is root 2 by 2, 1. Where we get 1, applying that 0, same 0, sin 0, no, 0 by 2 is 0 again, sin 0, 0, not equal to our required 1. And again applying tan 0, 0 by 2 is 0, tan 0 is not equal to 1, tan 0 is 0 itself. Cot 0 is not defined, it is actually reciprocal of that 0. 0 by 1, reciprocal is 1 by 0, it is not defined, infinity we can say. Cos A by 2, cos 0 is 0, so cos A by 2 is cos 0, again cos 0 is 1. So we get same 1. So we can say by substituting any value for A, we get this result. Even if this is trigonometric function, we can apply the value in option. Now the real method of solving this question, you need to understand what 1 plus cos A is. At the same time, you need to by heart 1 minus cos A also. These two have some relation. 1 plus cos A is actually 2. 1 plus something is actually 2. 2 cos square A by 2. You need to understand, if it is plus, that means plus is a positive symbol. You memorize that. It's a positive symbol. That means it is cos. Plus cos means the result is cos itself. Plus cos means cos itself, and answer is 2 cos square A by 2. Then minus cos definitely be, it is not cos. It's a negative of cos, not cos. Not cos means it will be sine. So it is 2 sine square a by 2. So 1 plus cos a is 2 cos square a by 2. 1 minus cos a is 2 sine square a by 2. Plus cos means it is cos. Minus cos means it is not cos. That means it is sine. So we can say 1 plus cos a is as 2 cos square a by 2 and 1 minus cos a as 2 sine square a by 2. So now let us look that question, square root of 1 plus cos a. So we can replace that 1 plus cos a as 2 cos square a by 2, 2 cos square a by 2 by 2. This 2 cancel each other, and square root of this one cos a by 2. And we get that answer cos a by 2 as in fourth option. Question number 10. Ck plus tan a equal to x. So we can say Ck as 1 by cos a plus tan a is actually sin a by cos a. In this case, both denominators are same and which is equal to cos a. So we can say 1 plus sin a. But there is no option like that. And our options are all in terms of sine. So we need to convert this cos to sine. So how can we convert that cos to sine? You know, the numerator is 1 plus sin a and the denominator is root of cos square a. We can replace it as root of cos square a. Cos square a we can convert it into sine. So 1 plus sin a is in the numerator and in the denominator it is square root of 1 minus sin square a. Okay. Now the numerator again 1 plus sin a, there is no change, but the denominator is actually like 1 square minus sin square a, like a square minus b square. What is a square minus b square? You know, a plus b into a minus b it is. So this is a plus b while 1 plus sin a comes here, and a minus b 1 minus sin a comes here. But you don't forget about the square root symbol. We can give it to separately or a single square root. Anyway, now this is actually 1 plus sin a, but we can say this is actually square root of 1 plus sin a into square root of 1 plus sin a. If two square root of 1 plus sin a are there, their product will be equal to 1 plus sin a. So that I am splitting it into two parts. Now this plus 1 plus 1, 1 plus sin theta, 1 plus sin a cancel each other, and this results a square root of 1 plus sin a by 1 minus sin a. So our answer is square root of 1 plus sin a by 1 minus sin a. Now this question we can solve by putting any value on a, but it is not possible to put 0 or value like sin 0, because while putting 0 all these values are same. So there is no possibility to identify which one is correct or not. So better you need to go with option like 30 degree, because our option we can either go with 30, 45 or 60, but our options are all sin a, sin in terms of sin. So sin 30 is a beautiful number, sin 30 is 1 by 2, another 2 bears a root. So comparison is quite difficult while we are going with the 45 or 60. So better you go with 30. For a student who doesn't know more about the trigonometry, then we can follow this types of technique. So sec a, what is sec a? Now here sec 30, tan 30. You need to calculate that x first. Sec 30, 1 by cos is actually sec. Cos 30 is actually cos 30, the value of cos 30 is 1 by 2. Sorry, cos 30 is root 3 by 2. So this cos 30 is root 3 by 2. Then we can say sec 30 as 2 by root 3. 2 by root 3. Then tan 30. You know tan 30 as 1 by root 3. 1 by root 3. You need to add these two numbers. Not plus multiplication, is addition. So we can simply say root 3 in denominator and 3 is in the numerator. On simplifying, root 3 is actually 3 is actually root 3 into root 3. So we can say root 3 into root 3 by root 3. 1 root 3 cancel. So remaining part answer is root 3. So this value is root 3. Which of our option leads to same root 3? That's our question. So for that, you know, sin 30, sin A is sin 30 actually. So now in first option, 1 plus sin 30 is 1 by 2. So 1 minus 1 by 2. So the numerator is 1 by 2. Denominator is 1 plus sin 30. 1 plus sin 30 is 1 plus 1 by 2, which is 3 by 2. That 2 cancel, and we get 1 by 3 in square root. So answer is 1 by root 3, but not our root 3. So this is not correct answer. And also that root is not here, so it is also not correct. It is also not correct. While considering this one is just opposite of this one, so definitely that will be just opposite of root 3, 1 by root 3, that means just a reverse of that number. So root 3 by 1, it is equal to root 3. So we get answer. So root 3, again this one is correct. So our answer is fourth option. Thank you very much for watching.